This is an intro to volume of solids with known cross-sections. In this video, I'll go over finding the volume of solids given a known cross-section. So in other words, a shape that is given to us, and it will usually be perpendicular to either the x or y axis. And so we can use integration to find the volume of those solids. So when you encounter a problem that asks you to use known cross-sections, it will be in this form. The question will give you the region bounded by two or more equations, and it will tell you that the cross-sections are perpendicular to either the x or y axis, and they are a type of shape. So in this case, the cross-sections perpendicular to the x-axis are squares. So the axis is x and the shape is square. Now the first step in solving a volume question is to draw a graph and input the equations given to us. So in this case we have y equals square root of x, which looks something like this, and y equals x, which looks something like this. It goes through the origin. And so once you draw that, we need to identify what shape we're looking at. So in this case, it's squares, right? And so the key detail is to understand what the area formula is for the shape given to us. So in the case of a square, the area of a square is s squared, s being the side, one side. And so after you draw the graph and input the equations given to you, second step is to find the area of the shape given to you, which in this case is s squared. And the third step is to identify what is s in this case. And since we know that the cross sections are perpendicular to the x-axis, we know that these small lines here is one side. So each of these lines are 1s. But how do we calculate the value of s? So we know that the value of y equals square root of x is this much, this length, this whole length. And the value of y equals x is this smaller, or this smaller piece. And so if you subtract the length of y equals square root of x, which is this big one, by the length of y equals x, which is a smaller one, we would get the length of this small region enclosed or bounded by the two equations. And so, long story short, you just need to identify what equation is on top, or what equation is on top of the other equation. So in this case, the equation that's on top is y equals square root of x, which is this equation, and the equation on the bottom is this equation, y equals x. And once we have identified what's on top and what's on the bottom, we can write that each of these sides is square root of x minus x. And now that is s. This is the value of s. And remember, the area of a square is s squared. So these two are equivalent now. After we found the value of s and we have inputted it into our area function, we can now find our bounds. And to find our bounds, it's similar to finding the volume using the disk or washer method. And finding the bounds, we simply set these equations equal to each other. So square root of x equals x, and you can solve this, or you can intuitively figure out that x is equal to 0 and 1, because the square root of 1 is 1, the square root of 0 is 0, so they're both equal. So once you have the two bounds, you can finally integrate or add it to your integral function. The lower bound is 0, the upper bound is 1, and our function is this area. So we input this function in, and we're revolving, or it's perpendicular to the x-axis, so it's in terms of x. And so that will give us our volume of the solid, because this is the area and we're integrating it to find the volume. Now, all we need to do now is simply evaluate this integral, and we can do that by expanding this. So expanding this, we get a squared minus 2ab plus b squared, which is x minus 2x to the power of 3 over 2 plus x squared. And once we've expanded that, we can add this in 0 to 1. And now we can integrate term by term. X squared over 2 minus 4 over 5 x to the power of 5 over 2 plus x cubed over 3. And so this we evaluate from 0 to 1, and the answer is something along the terms, or it is 1/2 minus 4 over 5 plus 1 over 3. And finding a common denominator, 30, we have our answer, which is 1 over 30. And so this is the volume of this shape, 3D object. And so to revise everything, our first step was drawing a graph and inputting our equations. Our second step was writing the area of the shape given to us. In this case, it was a square, so the area of the shape was s squared. And so we then find the value of s, which in this case, or in every case, it would be the upper equation minus the lower equation. So in this case, it was square root of x minus x. Input that into the area of the shape, and you get this. And next, we had to find the bounds. Find the bounds by setting the equations equal to each other. After you found the bounds and the function, you can finally input everything to the integral and then solve it. And so, same concept, we can write this. The base of a solid is a circle of radius 3 centered at the origin. Cross sections perpendicular to the x-axis are equilateral triangles. Find the volume of the solid. So in this case, it's quite similar, except a radius is given to us. And so it's important to figure out what is the formula for a circle, or what is the equation for a circle. And so if you had a minute to think about it, the equation of a circle is actually x squared plus y squared equals the radius squared. So in this case, the radius is 3, and 3 squared is 9. So this is the function given to us. And since we have this equation now, we can figure out what is y in terms of x, because the cross sections are perpendicular to the x-axis. So all of our terms need to be in terms of x. So y equals, isolate y equals 9 minus x squared. So now we can go on to our next step, which is finding the area of the shape given to us. In this case, it's an equilateral triangle. And so if you recall, the formula for the area of an equilateral triangle is the square root of 3 over 4 s squared. And in this case, this is not s. In the case of an equilateral triangle, each side is 2s. So in this case, it's 2 times r minus x squared. Right? And so now we can input this into our function. Square root of 3 over 4 times 2 times 9, square root of 9 minus x squared. The whole square. And so now all we need to do is expand this a bit, and we get something along the lines of square root of 3 times 9 minus x squared. So that's what we get when we expand all of this. And so once we have this function, all we need to do is find the bounds. And the way we find out the bounds is figuring out from where does the shape start and where does the shape end along the x-axis, because the cross sections are perpendicular to the x-axis. So in this case, it tells us the radius is 3 and it's centered at the origin. So if we draw the shape, it would look something like this, with the radius being here, and this is 3. This is also 3 because the radius is uniform. And so since we know this, we can add this to our integral, and the bounds will be -3, which is its place on the Cartesian plane, -3 to 3, which are our bounds. And we can input our function square root of 3 times 9 minus x squared dx. And once we found our function and our integral sign, we can now just evaluate this by integrating. And what we get is something along the lines of square root of 3. We can take the constant out, -3, 3, 9 minus x squared dx. And now we can evaluate this by saying 9, evaluating each term. This becomes 9x, this becomes x cubed over 3, and then evaluate this by -3 to 3. And don't forget you have a square root of 3 outside, so you need to multiply whatever you get here by square root of 3. And so when you evaluate this, we get the square root of 3 times 18 minus 18, which is 36. So square root of 3 times 36, which is, in other words, 36 square root 3. And so this is our area, or this is our volume for this solid. And again, we followed the same basic steps, but instead of drawing a graph first, we first figured out the function, because the function was not given to us. And so we figured the function out, and then we got the area, the formula for the area of the shape given to us. We found what S is, and then we plugged S in, and then we found the bounds. And this time we couldn't set two equations equal to each other because we were not given two equations. Instead, we used our intuition to figure out what the lower and upper bound is. And then we just integrated the entire thing. Here, the base of a solid is the region bounded by y equals x squared and y equals 4. Cross sections perpendicular to the x-axis are equilateral triangles. So the first step, drawing our graph and inputting our equations. Again, y equals x squared looks something like this, and y equals 4 is the horizontal line here. 1, 2, 3, 4. And what we're doing now is we're finding the volume of the solid bound by this area. And so next step is finding recalling the formula for the area of the shape. So in this case, it's an equilateral triangle, and so the formula for the area of an equilateral triangle is square root of 3 over 4 s squared. And now all we need to do is find s. So in this case, we can see that the equation y equals 4 is on top, and the equation y equals x squared is on the bottom. So all we need to do is subtract those. 4 minus x squared, which is our value of s. And so this square times square root of 3 over 4 is our equation. And now once you have our equation, our next step is finding our bounds so we can make the integral. Our bounds, we can just simply set these equations equal to each other, and we get x is equal to plus or minus 2, meaning when we write our integral, the lower bound is -2 and the upper bound is 2. Now all we need to do is input our equation, square root of 3 over 4 times 4 minus x squared over r to the power of 2 dx. And so now all we need to do is simply solve this. And we can take the constant out. So in this case, square root of 3 over 4 is the constant. And we can expand 4 minus x squared, the whole square. And so when we expand that, we get 16 minus 8x squared plus x to the power of 4 dx. And now, since we have simplified everything, we can now do the power rule and integrate term by term. And so after doing that, we get something along the lines of negative 8 x squared. Actually, get 16x minus 8x cubed over 3 plus x to the power of 5 over 5. Simply use the power rule on each of these terms. And that's evaluated from negative 2 to 2. And all this times square root of 3 over 4. And so when we simplify this, when we input 2 into the x and then subtract everything after inputting negative 2 into these terms, we get something along the lines of 320 over 15 plus 384 over 15. And so that gives us, let me make some room, that gives us 704 over 15. And keep in mind we have not yet multiplied the square root of 3 over 4. And so when we do that, we get 176 square root of 3 over 15. And so this is our final volume. This is the volume of the solid with cross sections perpendicular to the x-axis that are equilateral triangles. And so it's easy to find the volume when the cross sections are given to us. All we need to do is memorize the formula for the area of certain shapes and understand what the value of s will be. So to find the value of s, you just need to subtract the top equation by the lower or the bottom equation. And input s, find the bounds by setting the equations equal to each other, and simply solve the integral, and you'll get the volume.